So what I'd like to do now is invite all the speakers of today, as well as we very kindly have two speakers that came to our first session. So we've got Raj Dakar and Chris Binns, who are also going to join us. And what we're going to do is we're going to get sort of the feedback that we got from our breakout sessions earlier today. And we're just going to run through sort of the key takeaways we've got from them and have a bit of an open panel discussion about sort of where we think actually some of these challenges, the thoughts that come from the group, are they going to be addressed by these challenges, or are there other challenges we need to consider as well? So starting it off, the first breakout rooms looked at transport and energy systems integration. And this was focusing on road-based public transport, so like electric buses or very light rail. And of these, there's some misalignments actually sometimes with the transport energy provision and demands that could be overcome in the longer term through improved infrastructure. However, until that improved infrastructure comes, and it's always that chicken and egg type sort of moment, there is a challenge for systems engineering that needs to try and fulfill this gap to ensure that either new infrastructure bringing in or new systems are bringing in are able to not only comply with the legacy that's there today, but actually be able to support the transport modes of the future. And so from that, one of the key takeaway points that came from the room was around actually there needs to be risk assessments done to actually ensure that they're a driving issue, and so we understand what the risks of the network will be. So I don't know if anybody had any thoughts around actually sort of how risk assessments could actually help the future, provision of systems engineering. I'll go over to Chris, because you've got a train behind you.
Thank you. I was just wondering about that, because you do certainly have to take an overarching view. I think. I mean, if you take the example that's of the train behind me, the Elizabeth line, we have a whole infrastructure for the energy provision that allows that service to run. So 4 sources of power, alterations to the national grid, new substations, new national grid, supergrid transformers, to power the line. And that was part of the sponsored scheme from a very early stage. So I think that really is important. If you're adding, major changes to the infrastructure, it has to be an integrated whole, and it will impact upstream into things like the national grid or whatever the power system is that feeds in the particular country.
You also introduced new technology, didn't you, when you put the trains in that still have to run on the old lines, when you think about the ones that go to Heathrow, because it's always see both of them there. So you think, you still have to integrate old with new, or new with old. So.
Yes, and that's actually one of the complexities with the trains. There are 3 signalling systems carried on board, and 2 of them are for effectively the integration onto the national network. One is legacy and one is new. Yeah.
And so I think sort of then, Helen, from your perspective on mobility as a service, is there a way that we could ensure that actually the infrastructure itself, away from what perhaps the end user or end customer sees, is being sort of managed and controlled in such a way that could allow for optimization of, for example, energy supply to be able to provide power to buses or trains? Or is there something that mobility service can do in the background that's actually optimizing transport that isn't necessarily visible to the end user, apart from I've got a reliable service?
Yeah, I mean, I suppose I should say I don't really sort of myself work on any kind of, the actual transport infrastructure or transport modes. It's more the digital side. But yeah, I think it's an important point that MAS is a digital solution which relies on physical infrastructure, right, to be working properly and sort of functioning properly. So it's definitely important to kind of make that link to those 2 things. I mean, we're sort of looking at a bit of work on mobility hubs at the moment as well, and seeing how they might kind of, I guess they're the sort of bit of a physical manifestation of MAS, if you like. I think how mobility hubs might be a good solution for encouraging more people to use sort of public transport and linking up those digital and physical modes as well.
Brilliant, thank you very much. And Ian, any thoughts from yourself then around sort of the integration of transport, and for example in this case energy systems, but really sort of the wider systems integration piece as part of mobility as a service?
Yeah, I think we touched on a breakout room. I mean, in theory, you could have kind of backups for everything and backups for the backups and the backups, but there's not enough space, time, or energy. So there has to be some sensible kind of thought processes to kind of what service levels you need to achieve, what kind of regulatory space to kind of have that kind of minimum service that will get you through, and that sense of actually just understanding kind of how the availability, reliability stuff fits in with the service levels, fits in with the kind of integration so that you've got some sensible compromises that people are going to get behind. So it's just, yeah, it's that classic pragmatic systems integration, really, because you can't do everything.
Precisely. So another thing that I think would be interesting to get everybody's view upon this is sort of just, and it's a question that stems from one of the key points of what we thought about, which was communication is really key, and on implementing on project and infrastructure, ensuring that if you have a multitude of contractors, a multitude of businesses, that actually you've got a robust communication system in place, because otherwise one person changing one element could completely disrupt your final integrated solution. And I guess the question I kind of want to ask at this point is, how well do you think that communication is really happening today? So we'll go this time backwards, I guess. So I'll start with Ian, yourself. Sort of how are you seeing the communication happening today on the infrastructure projects or mobility as a service?
Well, think about some infrastructure projects I'm currently involved in. It's easy to form the consortium to build the bits. You can say, you're doing that part, you're doing that part. Everyone has their own specialisms, and someone gets the kind of PM part, and then the system integrator part. That's the bit where there always seems to be this kind of after you back and forth. No one's quite sure. It just needs to be much more strident. No, you're doing it. You're in charge of that bit, and actually, what in charge of it really means. And I think sometimes the boundaries and the governance of what the system integrator will be in charge of and also held to account against are not always that well defined early on. So it always seems to be that kind of running battle and conversation. So for me, it's that setting in place the right behaviours and the right governance, and not making it all top down, making it more collaborative, making it so that people, what's the phrase? You want pigs rather than chickens, because the chicken lays the egg and walks away. The pig is part of breakfast. So you want people to actually have a skin in the game, who want to be part of it, actually involved, and make sure they're involved somehow. And that way, hopefully, integration will follow, because it's in everyone's best interests.
Yeah, brilliant. Thank you. And Helen, how about yourself from integrating then the businesses? And I know we touched a bit on the presentation, the Q&A from that, but again, how is communication going today when you're engaging out with businesses?
Yeah, so I think probably our future transport zones work is quite interesting in that perspective, because we're sort of supporting local authorities as they're setting up MAS schemes. So yeah, it's not sort of part of my work personally, to be honest, but I know that's as you said, Ian, that kind of like collaborative working has been really important for them to sort of get those schemes off the ground. So yeah, that's probably what I could say at that point, to be honest. But yeah, I think it's such an emerging industry. I guess they're still figuring these things out as they're sort of setting up these schemes and as it's going now.
Yeah, exactly. And Raj, how about yourself? What are you seeing out there?
Well, for me, it would be like, I come from a data environment, so for me, I'd rather see as a code of conduct's being developed and you're negotiating things, you should start looking at the data model itself at that point. Don't just do a code of conduct, because that can go anywhere, but you should take a firm stance on trying to say, these are the things that we need to sort of capture as a baseline.
And then sort of how do you help translate that into making sure that all your parties really do then follow on with that? Because assuming that, if you've got multitudes of contractors, you're not going to be involved necessarily in every conversation they have. So it's how you ensure that's embedded to them.
That when you know the key fields that you want to exchange data with, you can then say, well, we need these, so what's it in your system? Do a data dictionary or an API or whatever. But as long as everyone knows the information they're supposed to provide and get back from the MAS, it's going to be a lot easier. Otherwise, you're just going to get a whole bunch of actors together. And I've done it so many times that you think you've got the right idea and you think everyone's on board, then suddenly it breaks, because that doesn't mean anything to me. That variable doesn't mean anything to me. So I think as you do the code of concept, you should really spend some time trying to develop the model first as well at the same point as you're negotiating with manufacturers or different actors. And it has to be done up front, because I think if you do it afterwards, it's going to be a typical IT project that just drags on for years, and then you just think, what the hell's going on? It's like, you need those requirements and fields up front, I think, because you know what you want to achieve. And it's just trying to recognize the things you want to get. That I would call them data elements.
Yeah, brilliant. Thank you very much, Raj. And Andrew, yourself over in Australia, because I know that having worked in various countries, there's sometimes very subtle differences with how everyone tends to work as well. But in terms of communication for yourselves, how's it going over there between all the parties to get this working?
Well, I think the thought that was running in my head now as the guys were talking was that this is one of the classic problems that we face right from the very inception often with these projects, is that when they're bid or created by the government bodies, whoever is purchasing it, they split the work up often into pieces. And that might make sense from a legislative, perspective, or whatever administrative perspective, but it doesn't make sense from a systems engineering perspective, because then you've got these entities, consortiums or JVs, whatever, that essentially aren't coordinating and aren't talking. And so we see that. So I think it's a problem. I guess where I'm coming from is that we've got to go right back to the very start. And when these projects are being conceived, they have to be conceived with the understanding of that you have these integrating, or these interfaces and integrations between them. If the people making the project's concept from the start doesn't understand that, then it's going to go pear-shaped before you even get off the ground. That was the thought that I had, because we've seen it at more recently, and projects are getting more and more complex, so it's becoming worse.
And I'll hand over to Chris there. I think Crossrail might be an interesting example to talk about it with this one.
Yes, it is. And I think one of our big lessons learned is you can't just delegate away system integration. So just as Andrew's saying, the project, if you take Crossrail as an example, was 46 different contracts. And the integrator always was the client. And in the middle of the project, we kind of lost our focus on that. And then what happened after the project was rescheduled and we put more teams into it, one of the big concentrations was actually on system integration and collaboration to get to the end result. So when we rebuilt the project after we missed our initial milestone, one of the huge concentrations was about the client taking a lead in system integration and being very clear what the goals were for the whole system, and then pushing that down through the contracts, but also encouraging the contractors in to collaborate. And that's where we were very successful in the end, with what I described briefly in my presentation a week ago, which was the Plateau and Plateau 2, as we called it. Plateau was the grouping of rolling stock and signalling contractors and platform screen doors, where we had very high levels of interaction between the systems. And then Plateau 2 was what we did on the stations, where again we had a high level of integration between the SCADA system suppliers and the builders of the stations themselves, with 500,000 digital elements in total being brought together. So yeah, huge lesson learned for us. Yeah, and collaboration is the key word, and the client can't just delegate away system integration. That's the other big lesson learned.
Oh, brilliant. Thank you very much. Yeah, I think that's sort of the perfect lesson to end the first challenge that we talked about on there as well. So the breakout rooms, two of our breakout rooms actually discussed around challenges facing freight transport systems in 2050, so with a bit of a futuristic view to it. And approaching this from a systems engineering perspective, how can a largely sort of unintegrated freight transport system that we have today transition into a more efficient, resilient cross-modal system that takes advantage of technology developments, such as using connected and autonomous systems, and have a significantly reduced environmental impact? Because let's not forget, as engineering, we need to think about the wider effects onto the environment that we're putting onto our new developments. And so what are the critical transport policy and strategy decisions that need to be taken to realise these potentials? And some of the key takeaway points that came out was that the systems engineering can help by capturing different stakeholders' needs in context and refine the solution down to exactly actually what the users really do need. Once they're understood as well, could do trade-off studies and modeling to understand sort of, your cost against speed, against environmental impact. So a bit of a different spin to quality, time and cost on project management, but actually looking at it using cost, speed and environmental as being a core factor to that. And then develop communities of practice to consider evidence-based and develop voluntary standards and legislation to drive relevant modal shifts on benefits. And then our other group actually gave a lot more thought around data availability and actually going, well, we need to make sure we've got data available to be able to help our end users even understand perhaps what they're getting before it's there, which can feed back in at an earlier stage to design some better decisions into what comes out as a final product. And then there's the systems of systems approach, which again is the top level view of a systems level to ensure that when changes are made in one system, we understand what the impact will actually be to everything else. And that's that's actually now trying to look at, I guess, the processes that really help at that middle strategic level, the communication element we talked about, to ensure that, you know, we understand changes as programs develop. But I think in this case, starting with yourself, Raj, on this one, is for the challenges facing the freight transport in 2050. Sort of how could systems engineering actually help us deliver the future freight? You know, the future of freight. How are we going to get there?
Well, it's kind of like what you said. You've got to map out the requirements and then do a systems approach. But you can use lessons like if you look to the construction industry, they were in a very similar state to you guys, but they created something called BIM, the Building Information Management System, and so now they can get like the labourers on time, the materials can arrive on time, the drawings are on time. It's like an information management scheme. That's the only one, and that's the one that goes end to end. I'd say BIM was probably the classic example, but you take learnings from other systems, apply it to develop a model like that, because BIM is quite heavily used now. It's like taken years to do, but any building over a certain size has to have a BIM model that covers all the design aspects, all the construction aspects, all the environmental aspects, and all the interconnectivity aspects. It's like learn lessons from other industries, but I would say BIM is probably the best one to use as an approach.
Brilliant, thank you very much. Andrew, over to yourself. What about your thoughts on this topic?
Yeah, well, you need to have that. Raj is obviously right. You need to have the requirements model up front, because the thing is here that what you're wanting to do is to be able to continuously analyze that system, that model of the system, looking for opportunities where you can improve the system. What might have been a good solution at the point when you developed it can be 10 or 20 years later no longer the right solution, depending on what other technologies have arisen. So, and we're seeing that with our customer Rio Tinto, that we built the order hall system effectively, designed and built it now really 10 years ago. And 10 years is a long time. And so we see a lot of changes and improvements and available. And the fact that we have done the hard work in the beginning to define the requirements of the system accurately has put us in good stead now for when we do this optioneering. We're able to make those assessments accurately and know what parts of the system that we're talking about when we look at particular studies that are being done for improving various functions of the system. So yeah, it's an obvious answer, I know, but that I think is the crux, is getting those requirements right from the very beginning.
Yeah, you have to agree to spend the time doing it when everyone hates doing it because they just want to sign a contract off, but you have to do the work up front.
Yeah, that's right. So it's hard to say to people, well, you know, put your hard yards in now because this will pay off for you 10 years down the track. So, you know, it
usually goes the other way as well.
Guys, you know, when we try to tell people that they need a function to have safety integrity, it's because, you know, for this rare occurrence, but not so rare that we want to risk it.
Yeah,
sorry, Raj.
So I was going to say, when projects overrun, the first thing to do is cut the training and then wonder why the users are making mistakes. It's that kind of logic. You need to invest that time and effort up front to avoid issues.
Definitely.
Great stuff. Thank you very much for that. And yeah, it's one of those things, I think we talked about it a bit in sessions last week, was about the fact that there's always this rush that as soon as money gets spent on something, being shovel ready is kind of the great rush to try and show something physically tangible that something's happening. But actually, are we just rushing for the sake of, you know, creating problems later down the line by not giving it that due thought?
It's milestones, isn't it? If you put a proper milestone in a project that says get the requirements right, rather than give me payment for doing something that's not really the end thing, it's just a milestone payment that people just rush, like it's been said before, people just focus on milestones.
Yeah, exactly.
I mean, the phrase you see nowadays is the phrase you see nowadays is that shovel worthy rather than shovel ready.
Yeah.
So is it actually worth lifting the shovel yet, or should we just?
Yeah, I agree.
That's a great term. I'm going to use that from now on. Michelle, any thoughts from yourself?
Yeah, sure. I'm fully agree with such a discussion, and we need to consider often that technology is the very last step that we need to add to the project, and too often we go in the opposite direction, and we choose technology quite early in the project, and when we going to finalize it, that technology looks already a bit old or not the very last, and therefore we enter in a cycle of difficulties. And so that is one lesson learned. And about the other topic I mentioned before, communication is of course a pillar. It's never too much, never too clear, I want to say. Maybe too much discussion, but not too clear communication. And system thinking approach is another lesson learned that is really needed to avoid a lot of mistakes.
Brilliant, thank you very much. And then Helen, just something from the math side of things from DFT and the policy coming together. Sort of anything in the policy that you can see for now that could actually help sort of get to that 2050 modal shift for other users. So again, not just perhaps sort of customers or public transport customers, but actually freight being included in part of this.
Yeah, so I should say we have a full sort of future of freight team at the department that sort of works on this every day. So it's definitely something that's kind of being considered and sort of worked on, and kind of slightly out of the scope of my job really. But yeah, hopefully I think, as MAS sort of grows, then the benefits of that approach can hopefully be seen by other industries outside of transport as well, actually, and kind of, yeah, hopefully taken on in those ways as well.
Oh, brilliant, thank you very much for that. So then the final breakout room that we had, which was room 3, which was around mobility as a service and data sharing. And this again is there's many challenges to the success of mobility as a service. The social, commercial, and political barriers between the modes need to be overcome to provide seamless travel experiences for users. And it's quite likely that systems engineering is going to play a part in solving these problems. But the focus of systems engineering influence is likely to be in the operational realm. And the challenge actually is how can widely sourced data be confidently sort of used in a mobility as a service environment? So the takeaway points from the breakout group that held the session was that mobility service acts as a conduit for travelers, operators, data and services. This requires integration at technical, operational and commercial levels to succeed. And systems engineering is sort of essential to actually achieving that. The commercial agreement is to determine how all needs are met. So, systems engineering is vital to actually establishing the commercial as well as the other end user needs. And there are concerns over data security and emerging regulations relating to AI and the design of the interface, and that systems engineering helps to fit mobility service into complex regulatory environments. Standards for data and interfaces are likely to be really significant to help achieving that. So starting off with Michelle yourself, sort of how do you see kind of the challenges being overcome with data sharing across all our transport modes, not just operators within them, because that's enough of a headache today, but actually across all the modes that exist out there if we're going to achieve this?
Yeah, the topic is very much open and a lot of challenges there. However, data is a kind of goal point for the future, the automation. And one approach that is going to be established is using labeling, metadata, in order to give a kind of quality of the data that you are using. Because one of the main challenge that we have in automation is let's me simply speaking say, the good quality of the data that you are using. That is fundamental. And one approach currently we are trying to using is to mark the data, or somehow, I don't want to go into much details now, but to mark the data according to their quality, according to the source and so on, and then use such metadata, such labeling across the process. That may help to facilitate one of the challenges that we have.
Oh, brilliant, thank you very much. Andrew, how about yourself?
Well, that's not a new problem, obviously, in terms of systems integration, that you have different parts of the system that need to exchange data, and you need to define the interface between those parts. But the complexity, I think, that you're going to encounter with the mobility as a service is that you're going to have potentially multiple different stakeholders or suppliers. So the conversations on the interfaces that we're talking about here isn't within a system that's under the control of a single, necessarily within the system that's under the control of a single integrator. So, and maybe it's not necessarily practical to put an integrator across all of those systems. So that's, I think, is the issue, is when you have these multiple entities that are then needing to define the interfaces between them. There's a big increase in complexity because you don't have the collaboration and don't necessarily have the collaboration and cooperation to make those interface definitions in an efficient manner. And I don't think it's a problem that's been solved yet. Even if maybe the answer is obviously we need to have that overarching integrator, but then, you know, how you effectively manage that role, then that's you know, an open issue.
Brilliant, thank you very much. Go on, Chris.
Yeah, do you mind if I leap in on that? Because I think one of the things here that is an interesting challenge when looking at MAS actually is you need to get to the decision makers that are running the transport network. So if I just use, you know, a part of MAS, which is the National Network for Trains in the UK as an example at the moment, when you get severe disruption, the information displays are useless. If we're honest with each other, you can be standing on a platform and the train will arrive in another platform. The reason for that, you know, loss of integrity of data or quality of data is because we don't get to the decision makers, and those decision makers are partly machine and part human. So there's automatic route setting, which is changing its mind about priorities and where to put trains and which one to go first at a junction and that sort of thing when there's big disruption. And there are human controllers who are also making decisions about whether to turn a service back, cancel a service, skip a station, and so on. And the provision of information doesn't at the moment take that into account very well. It tries, but it doesn't, and it doesn't succeed. And everyone who's used the UK network will know that in times of most severe disruption, the display of information is the worst, which is just when you need the display of information to be the best quality. So I think you know, this really resonates with me. And when we look at MAS, I think that's going to be a huge challenge. So if we're integrating across loads of different providers, how do we get to the decision makers in those providers? Those decision makers, when there's disruption, deciding to cancel a service, skip a station, not run a bus, you know, the bus has broken down, so it's stopped, you know, the lorry, whatever it is, the boat, you know, all these different modes of transport all have decision makers, some of which are machines. So we need to get into those to get the data out to the market, to the user. So I don't have an answer, by the way, but it's a huge challenge.
But that's very much in line with what I try to say with the labeling. We need a kind of quality of the data. That's pretty much in line with what you're saying.
And I think then it's getting to the decision makers. So how do we make the data more a higher quality, more effective? Label it that this is the latest data because a thinker has done something and made a decision. At the moment, we can't get to those decision makers very easily.
So Helen, what's your thoughts on that and being able to enable sort of various industries to be able to get to these decision makers that can enable MAS?
Yeah, I mean, I don't have a sort of specific answer on that, but I would say from the kind of code of practice point of view, we are trying to address some of these issues through that. So kind of, as you mentioned, absolutely data quality, really, really important. You know, standardizing the data, data sharing as well, of course, it kind of, you know, completely underpins everything sort of to do with MAS really. So yeah, we've got a section in there on data and just providing some recommendations around the types of data we'd like to see shared, how organizations can do that safely and kind of complying with all the relevant regulations. We're trying to sort of pull together a resource of like, yeah, relevant regulations, relevant government strategies, anything that kind of can help organizations when they're setting up these schemes to kind of make sure, yeah, they're sharing data in the appropriate way and that it's of the highest quality possible, really.
Any of those schemes actually launched yet?
Yeah, so the Solent Transports have just launched a MAS scheme, which is part of the Future Transport Zones program that we run. I think that launched about a month ago, so it's quite new. But yes, they do have an app. It's called Breeze, and I think it is available to download on the App Store if anyone wants to take a look.
Yes, for me, that would be the first one that you sort of handhold and then try and develop a model from, because you're at a very early stage. And then you should be able to transpose something that's going to be common, that can be reusable. So you guys should be leading not just with the code of conduct, but getting some engagement between the actors to say, we need this, we need to get something commonality between everyone. and use that as a test bed, if you like.
Yeah, I mean that's kind of the idea of the future transport zones. Really, is that they're kind of a trialing, part of the program that we can kind of work closely with the local authorities and support them as they're trying to set up these schemes and trying to address some of these issues as they crop up as they go.
Yeah, because you need that commonality. I think if you just did it as a pilot and with a code of conduct, you're not going to get very far, because it's like you're still going to have issues, I think.
So then, staying on focus of the data quality and data sharing amongst each other, Ian, over from from work with cybersecurity, how can you imagine that we can ensure that actually there are no threat vectors that come in that either completely tank out mass or even worse, negatively affect operators in their own operation of services?
Well, I guess the standard approach is trust no one, trust nothing. So you assume you're not untrusted networks, you act accordingly. But also, all seriousness is what a lot of people are doing, because there's a recognition that you don't quite know who's where and who's what, so you have to set yourself up from the start to be acting in an untrusted way. And so effectively, you've got the obviously the data standards and things there to underpin it all, but at some level, there's a lot of kind of handshaking to make sure that everything's done without risk, or at least you can lower the risk down. I guess you also need to think about the level of coupling you have in there as well, so you don't leave yourself open to some kind of attack that just comes through from nowhere. I mean, certainly one of the bigger things now is it's that kind of thing where you get cyber attacks that come in not operationally, but they're implanted during development and they don't manifest themselves till later. So it's actually understanding that if this is going to be a highly coupled thing that everyone uses in the UK to get around, you've got to be thinking a long way back in the timeline to where you need to start protecting. Otherwise, it's a golden egg for someone to go in there, plant a thing early, and then turn it on later.
Yeah, because I used to do that in defence, where you could always design it first, and then you pen test it at some point to make sure it's as much as you can.
I'm told there's all sorts of ways you can do that and still have something going a bit later.
Yeah, but
So just on the one thing I wanted to bring up, which hasn't come through, is on the work we did on our future logistics stuff. One thing we found very powerful was having a system dynamics model. So every intervention we proposed, we'd have a system dynamics model that someone had created of an example logistics scenario. Now, it was a bit scenario dependent. We had to eventually get to make a few more, so we didn't get weird effects that only worked in certain situations. But every intervention we came up with was then somehow characterized to how would it affect this scenario. They're going to run it through, and we can see a kind of system dynamics effect of what's changing. And you see different pinch points, different bottlenecks, different behaviors emerging based on what the model would predict. And that kind of thing, I think, is actually very powerful for these kind of future-facing sort of systems changes. Where actually, if you can model an approximation in Vensim or something appropriate, that will give you a thing that looks about right when you compare it against known reality now. At least then you've got the chance to say, if we do make these changes, let's play with it in this space first, then perhaps go to synthetic environment modeling, and then finally go and do the thing.
Yeah.
Rather than just marching forward to all the great ideas.
Would you do that off? You wouldn't do it as a digital. It's technically a digital twin, but you want to
yes,
a data model.
Yes and no.
I'd say no. You don't want to model it.
Yes and no. It's a kind of precursor to thinking you might need to put in place to do it properly as an actual agent-based, item-based twin. But the kind of higher level systems dynamics modeling, the kind of causal loop type stuff, you can do it at a more abstract level just to get a feel for things, and then play that through to see how it works. It's quite a nice shortcut to having to get everything in.
Again, it's upfront work though, isn't it? It's all that sort of.
It is, but if it helps make the case.
100%, yeah, I agree with it.
So as we're getting towards the end, I've just had a quick scan of any sort of outstanding questions on that. So what I'd like to do then, as a final round robin, one at a time sort of thing, is just sort of from your perspective, what is the greatest value, and how do we achieve that greatest value with systems engineering to get to where we want to get to with all these different systems coming together from various transport modes, whether that be for mass or for any other purpose. Sort of what is the key takeaway that as systems engineers, or perhaps discipline engineers that are learning about systems engineering, what is the key thing we need to focus on? So I'd like to start with Helen, yourself.
Yeah, sure. So I think for us, the work that I do really sits within the sort of decarbonisation and net zero work that we do at the department. So I'd say that everything we're doing on MAS is really through the lens of trying to decarbonise transport, encourage more people to travel actively, to travel on public transport, and realise the benefits of that. So yeah, for me, that's kind of the main purpose, and kind of from the department's point of view, where we see MAS really sitting is to just achieve those net zero goals.
Brilliant, thank you very much. Andrew, yourself, how about sort of, systems engineering? What's the key thing we need to focus on?
Risk, I think, that I was just thinking when the guys were talking a moment ago that how we do a pretty good job. I think I mentioned this in the breakout room as well. We do a pretty good job when the system is a safety related system. We've got good processes. When the system is not a safety related system, I think the systems engineering processes are not as good, because there isn't that driver of risk, but there should be, because risk isn't just about safety. There's all sorts of and many companies, have their risk frameworks that acknowledge other types of risk. But I think that when, as systems engineers in general, not as active in that space, maybe not supported in that space, but need to be more active in that space. A risk-driven approach is the key. Yeah.
Brilliant, thank you very much. And Raj, yourself?
I'd agree with Andrew, because it's like I've had experiences doing exactly the same, where if it's not in the core safety part, everyone tends to ignore it, but it's a mixture of that with getting the requirements up front and doing it, spending more time defining the requirements before you just go into something.
Yeah, very good point, very good, thank you very much. And Chris, how about yourself?
I think for me, it builds on what Andrew and Raj are saying, actually, but it's considering the whole life cycle right from the beginning. So it is about getting the requirements clear, but it's also about thinking to the end game. And just to really bring it into rail, and the difficulty we have today is that rail projects, particularly the control systems, were traditionally bought with a 30-year life and then sweated for 40 years, typically. Digital control systems, you need to be updating all the time, not only for cybersecurity, or not least for cybersecurity. So, it's a very different model. And I think we don't always think of that as a requirement right at the beginning of the project. There's going to be significant investment every single year in changing the digital systems, responding to obsolescence and so on. And that's the reality of the new world.
Thank you very much. Very, very good point about obsolescence management in there as well. Ian, yourself?
Well, I've been giving two answers all day, so I'll carry on in that form. On the one hand, it's the good engineering management. It's that kind of, the rigorous writing stuff down, doing traceability, making sure the arguments stack up, communicating, doing the change management, all those good things we know should happen for well-managed engineering projects, so that the whole thing hangs together properly. And of course, the second part is the secret sauce of systems thinking. It's that taking a step back, looking inside, looking outside, looking forward and back, looking across the whole thing, and just having that bigger holistic view and following those loops around to make sure that you can work out how to get back to where you started from. Because you can be systematic and do great engineering management, but if you've lost track of what you're doing, that's not necessarily going to help you. Equally, if you're holistic and don't do the management, you'll also not get very far. So the two things have to work together.
Brilliant, thank you very much. And Michelle, last but not least, yourself.
Thank you. I never stress too much the overall approach. I fully agree with the last colleagues. To me, as I tried to present in my presentation a week ago, the system engineering and the system thinking are the two sides of a kind of DNA helica, and they are going together along the full life cycle of the project. So the system thinking approach is very much needed, and everything is constantly updating. That's my main takeaway.
Oh, great, thank you very much for that. And we're now getting to the point where actually everything comes to a close. So first and foremost, I'd like to thank you to all of our speakers here that gave talks today, and those that actually returned from us from session one, where the recording's available as well, to be part of this panel discussion at the end.